Thanks, Doug. I found your motivation at the beginning particularly refreshing because I and you and Linda have been on a bunch of these kinds of panels in the last couple years where two sides that were supposedly disagreeing ended up actually being there being more consensus than it appeared at the beginning. So I actually think that if you polled most of the experts in this field, you would find consensus in that somewhere between 20 and 50% of the weight in teacher evaluations could and should be placed on student achievement measures. Now, that's not, though, the way that the issue often gets framed. So I'm actually going to try to do a little bit of a reframing here. Instead, rather than saying, okay, let's have a debate about whether it should be 0 or 100, I'm instead going to say, all right, what would you have to believe in order to argue that student achievement gains should play no role? And let's assess the evidence on whether or not those beliefs seem to hold any water. Because I think rather than having more debates that seem to be arguing whether or not we should be including value added, rather we should be arguing about how it should be used, as Doug was suggesting, and how the other parts of the evaluation process, namely the classroom observation and potentially the student survey, could be improved. So let's see if I can, my goal then is to try to shut down the old debate and move on to the new. So if I were trying to make the case for 0 weight, what would I argue? Well, first thing is I would try to say, okay, value added in any given year provides no information about future years. Because if it did provide some information about future years, that would argue for including it in some kind of measure. So what's the evidence for the claim that you have to believe that value added provides no information about a teacher's student achievement gains in future years? Well, one way to do that is to do a little thought experiment where you say, what proportion of those teachers who are in the bottom decile in terms of value added in 1 year were in the bottom or top quartile over their career? And over their career, this is literally in 3 different districts we could identify measure value added in 6 or more years. So there are a few districts that had data that would allow you to calculate value added over multiple years. And so we could just do the calculation, not a simulation, these are real data, where we could say, okay, suppose you just used 1 year of data, identified the teachers who are in the bottom decile in terms of value added in that 1 year, and then look at their average value added over their career and see, what was the relationship. Well, these are from 3 different districts. The first 3 columns are in math, the second 3 columns are in English language arts. So of those who were in the bottom 10%, 67% in District 1 were in the bottom quartile over their career. 81% in District 2 were in the bottom quartile over their career. 70% in 3. A little bit lower in ELA in Districts 1, 2, 3. Now, what proportion were in the top quartile over their career? Well, not 0, so it's not that value added in a given year is a perfect predictor of the career, but only 3% of those who were in the bottom decile 1 year were in the top quartile over their career. If there were no information in the single year value added, you'd expect to see 25% there. So that's obviously much lower than 25%. So it is demonstrably not true that value added in a given year provides no information about a career. That should be the test for the argument that this is all just statistical noise. A second argument one would have to make is okay, value added is bias due to unmeasured student traits. Well, again, that's possible that that value added is so biased that it provides no information. But again, what would you do if you actually seriously wanted to test that hypothesis? Well, you'd say, okay, if we randomly assign teachers to classroom, would their prior value-added scores predict how well their students performed after random assignment? That's the way you test whether or not the value-added measures are so hopelessly biased that they don't provide you with any information about the causal effect of a teacher. So if we were serious about that claim that value-added measures are entirely biased, we'd actually do the test. Well, we did do that in the Measures of Effective Teaching project. In the second year, we randomly assigned classrooms, and the goal was to see whether the measures that we collected the first year had any predictive power, because that's the only way to test the bias. Well, what did we find? Well, these are breaking the MET sample into 20 different groups. Along the x-axis is their predicted effectiveness. On the y-axis is the actual achievement following random assignment. So this is using a value-added measure to predict how well a teacher's students would do following random assignment, and then just checking to see whether that prediction ended up working. And the dotted line is just the line where actual would equal predicted. So it's not the fitted line, although it turns out that it would be the fitted line, that the actual achievement following random assignment, on average, matched pretty well with the predicted achievement. Okay, what would be the third argument you'd make if you were trying to argue for zero weight? Well, you'd say, okay, value added is completely unrelated to what experts consider to be excellent instruction. Well, what's the evidence on that? So what would you do? What thought experiment would you run if you were interested in that question? Well, the first thing you'd do is you'd say, suppose we scored a bunch of teacher videos on a number of different rubrics and made sure that the observers who were observing them didn't know what those teachers' value-added scores were. So let's make sure that the observers had no idea what the student achievement gains were in that classroom, and let's have them apply a number of different rubrics to watch the videos, and let's see how the scores were related to the value-added scores. Because, again, let's test the proposition that this has nothing to do with excellent instruction. Well, what do you find? Well, on the state math tests, using 4 different rubrics, the MQI, the UTeach, Teacher Observation Protocol, Class, Framework for Teaching, there's a positive relationship between the scores people got on the classroom observations and their value-added score. It's not perfect, there's not 100% correlation, but again, in order to argue that they should play no role whatsoever, you'd have to say it has no relationship to a teacher's student achievement gains. And again, that's clearly not true here. Now, one thing I would call out is in the bottom 2 panels is that there is a stronger relationship between classroom observations and student achievement measured in a literacy test that required kids to do some writing. So the Stanford 9 open-ended reading test was a reading comprehension test that required kids to write short answers to their questions. There was a stronger relationship between classroom observations and that outcome. Now, we could come back and talk about that, because I think it does have implications for the way we measure student achievement gains in literacy. But even in ELA, there was, using the existing state ELA test, there was a relationship. So it's just not true that value added is completely unrelated to our views of excellent instruction. Okay, what would be a fourth thing you'd want to argue if you were going to argue for the case that student achievement gains should have no weight. Well, you'd say achievement gains on the current tests are completely unrelated to the Common Core. Not to say it's distinct from the Common Core. That's true, but to say that value added provides no information about how well a teacher's students will do on the Common Core tests. So to say that value added on the current test should not be used at all because we should put zero weight on them because we're about to move to the new test, you'd have to be able to say they tell you nothing about how the kids are going to do on the Common Core tests. Well, that is a testable hypothesis. So New York recently moved to a more Common Core aligned state test. We can calculate teachers' value added in 3 different years: in the 2010-11 school year, old test; 2011-12 school year, old test. That's a typo. It's 12-13 in the new test. So in this last year, and we could just say, okay, what was the correlation at the teacher level in value added scores between 10-11 and 11-12 when it was the old test? Correlation was about 0.51. Well, it's not zero. I would argue to argue that it should have zero weight, you'd have to argue that there's absolutely no relationship there. And that's not the case. So I don't think anybody would argue that the weight should be 100%. But again, we're testing the argument that the weight should be zero. And I think this is the right way to think about it. So if there were no relationship, if the value-added scores on the old tests had no predictive power for the new test, we'd expect that correlation backwards to be potentially positive, but forwards to be zero. Well, what was it? It was 0.46, so slightly lower than 0.51, but certainly not zero. So again, if you're all of this using value-added classroom observations, student surveys, is using imperfect indicators to try to provide feedback to teachers and their supervisors on how well they're doing. All of this is going to be imperfect. To argue that one component should play no role whatsoever, you'd have to argue it provides no information. And again, I just don't see that in any of the data we've looked at. Now, if the goal were to predict value added over a teacher's career on the current state test, what we found in the Met study was that you'd put a huge amount of weight on it. You'd put 75, 80% of the weight on value added if your sole goal were to predict value added in future years. But of course, that's not the only goal of these systems. The goal of these systems is you have to worry about reliability, you have to worry about outcomes that you're not measuring on the state tests, you have to worry about how you're providing feedback to help people improve. And that's why in the Met report we ended up arguing for the 30 to 50% range and not the 80% range weight on these things. Now, just to give you some sense of that, we tried to quantify what some of these trade-offs are. So we said, okay, let's test 4 different models. Let's start with model 1 is the extreme where your goal is just to predict a teacher's students' outcomes on the state test. What would you do? Well, in that world, you'd put 81% of the weight on value added on the state test. This is in, I think, middle school ELA, these numbers. But you'd see similar results in elementary school and in middle school math. Model 2 says, okay, Suppose we backed off that and we said 50% weight on value added, 25 on the other two, student surveys, classroom observations. Model 3 is a third, a third, a third. Model 4 is going further than, down weighting value added to 33%, going all the way down to 25 and putting 50% of the weight on the observations, which actually is closer to what a lot of states are doing. So we said, what are the implications of those three things, or those four different weighting schemes with three potential outcomes? One is correlation with state test gains. And what you see is, not surprisingly, as you move away from Model 1 to the other models that are weighting the classroom observations and the student surveys more, you're lowering the correlation with the state test. You're lowering your ability to predict which teachers will have strong state test gains. But at least initially, you're gaining some other things. So the correlation with these other tests, the tests that require kids to do some writing, does go up a bit, at least initially. But what often happens is if a little bit of something is good, it does not necessarily mean that it's always better to get more of it. So as you downweight the state tests and you start to put more and more weight on the classroom observation, you lose some of the things that you care about. You're actually losing some correlation with these other tests that presumably are measuring skills that we care about. Now, similarly with reliability, so as you move from Model 1 to Model 2 to Model 3, the measures become less volatile. They become more stable from year to year. Why is that? Well, that's primarily being driven by the fact that the student surveys, believe it or not, are among the most reliable of the measures that we tested. Now, at first, that might seem counterintuitive. Like, how could it be that a student's observations or impressions of a class are more consistent from year to year than an observer? Well, an observer, it's easy to imagine that a trained observer would be more discerning than the typical student that's filling out a student survey. But the way you get increased reliability with an adult observation is to average over multiple observers. Well, in the student surveys, you're averaging over 25 kids in an elementary school or 75 or 100 kids per teacher in a middle school. And it's that power of averaging that generates the higher reliability of the surveys. But notice that even when you go from 3 to 4 and you pump up the weight on the observation and you downweight the student achievement gains on the state tests and the student surveys, in that world you actually start to lose the thing that you care about, reliability. So this framework was the one that we used for saying, hey, look, predicting future gains on state tests is not the only thing you care about. There are other things you worry about, correlation with other outcomes, reliability. But it's not obvious that if the goal is those other outcomes as well, that you'd abandon the state test. Quite the opposite. If you go too far in downweighting the state test, you lose some of those other things that you care about.